On a clear night near the poles, the sky can come alive. Vast curtains of green and violet light rippling and dancing overhead in total silence. People travel across the world to see them. But what actually causes the northern lights? The answer begins not here on Earth, but 93 million miles away, on the Sun.
Our sun is a roaring ball of plasma, and it never sits still. It constantly blows a stream of tiny charged particles out into space in every direction. This is the solar wind, and it races across the solar system at over 1 million miles per hour, carrying a little piece of the sun toward every planet, including ours. When that storm of particles reaches Earth, something invisible protects us. Deep in our planet's molten core, swirling iron generates a giant magnetic field that surrounds the whole Earth. This magnetic shield deflects most of the solar wind, steering it harmlessly around our planet, like water flowing around a stone. But the shield isn't sealed everywhere. Near the north and south poles, the magnetic field lines dip down and funnel inward, so a fraction of those solar particles get channeled down along these lines, pouring into the upper atmosphere in rings around the poles. That's why auroras appear near the far north and far south, and rarely near the equator. Now for the magic. High above the ground, the incoming particles slam into atoms of gas in our atmosphere, oxygen and nitrogen. Each collision gives an atom a jolt of energy, and when the atom settles back down, it releases that energy as a tiny flash of light. Multiply that by trillions, and you get a glowing sky. The colors are a fingerprint of which gas is glowing and how high. Oxygen high up glows that classic green, the most common color. Even higher, oxygen can shine deep red, and nitrogen adds blues and purples along the lower edges. The aurora is literally the air itself, lit up by the sun. Sometimes the sun throws a tantrum. It can hurl a huge burst of particles all at once, a solar storm. When one of these hits Earth, the auroras flare brighter, dance faster, and push much farther from the poles. Sometimes far enough that people in cities rarely treated to the show suddenly look up in astonishment. These same solar storms do more than paint the sky. They can ripple through our technology, disturbing satellites, radio signals, and even power grids. So scientists watch the sun around the clock, forecasting space weather, because the same particles that make beauty can also cause trouble. Want to see them yourself? Head far north to places like Norway, Iceland, Alaska, or northern Canada in the dark winter months. Get away from city lights, look toward the northern horizon on a clear night, and check an aurora forecast. With a little luck and patience, you'll watch the sun and the sky put on a show together. So the next time you see those glowing curtains, remember what you're really looking at: particles from the sun, caught by Earth's magnetic field, lighting up the air 90 miles above your head. A connection between a star and a sky, stretched across the emptiness of space. And if there's a science or space mystery you want explained next, tell me in the comments. Your question could be the next video. If this made you a little more curious about the world, subscribe to the Binary Brew, and I'll see you in the next one.